Alright, so today we will be looking at inorganic chemistry. So we have completed organic chemistry for now. So we're going to look at inorganic chemistry. And today specifically we will be looking at the metals. So we're not going to look at any non-metals today nor the qualitative analysis. We're going to strictly focus on metals today. Alright, so we need to know about the reactivity series. Right, because reactivity series is a method of grouping the metals in terms of their reactivity, and then that will govern the different types of reactions that the metal will undergo. Alright? So in general, principle of the reactivity series is group 1 metals first, most reactive, then group 2 metals will be second in line, then group 3 metal is third in line, and then the transition metals. So if you take a look, the transition metals are those metals between group 2 and group 3 of the periodic table. They are transition metals. Clear? So now in terms of the reactivity, right? I remember that we didn't really discuss periodic table in much detail, but when I was discussing how atoms formed by losing electrons or gaining electrons, remember that the metals are elements, are atoms that normally lose electrons to become stable. So the easier the metal is to lose the electron, the more reactive the metal will be. Alright, so that is why when we talk about metals, the lower down in the periodic table in the group, like group 1, the lower down you go in group 1 of the periodic table, the more reactive the metal will be. Alright? However, for C-Sec chemistry, we normally going to look at like the first 3 elements or the first 2 elements in group 1, the first 2 in group 2, and aluminum from group 3. Right? So that is why we go potassium, most reactive, then sodium, next in line. So those are 2 group 1 metals, right, Mr. Harding? Group 1 metals, and then potassium is lower in group 1 than sodium, so it is more reactive than sodium. Alright? If we move to group 2, we have calcium, magnesium. Calcium is lower in group 2, therefore calcium is more reactive than magnesium. So next would be calcium, then magnesium. Right? So this is the reactivity series, you know, so we're going down in terms of increase in reactivity, decrease in reactivity, sorry. So at the top is most reactive. Down here is least reactive. All following thus far? Parks, McFarlane?
Yes, sir.
Good. So this is 2 group 1 metals here. We have 2 group 2. Then we're going to look at aluminum. Right, so it is next in line in terms of reactivity. Alright? So as you can see, we have this in group 1, these 2 are group 2, aluminum is group 3, right? And then further down, least reactive metals are normally the transition metals, right? And example of some are zinc, iron, have lead, hydrogen, copper, mercury, hydrogen is not a metal, however we're going to place it here to have an idea of the reactivity when compared to hydrogen. Alright? That's the reactivity
I
series.
don't hear, sir.
I'm saying that hydrogen is not a metal. This is the reactivity series for the metals, right? However, but this is not, alright?
This is not a metal.
No, alright? So copper and silver and gold, alright? So, however, normally what most students will do to remember is to come up with some acronym to remember, because this is going to be a very, very important series of metals to remember. So I saw one online where it said, please send cats monkeys and zebras into lovely hot countries. You can put sign general. It was general Philippine for platinum down here, but because platinum is not in the book that I'm using, I'm just going to leave it. Because you probably don't need to really focus on that so much for the exam, for CSEC. Alright, but as you know, the reactivity series, the entire series would basically include all the metals. So it's just selective metals we use it, right? So the general trend is group 1, group 2, group 3, then transition metals, right? So remember the symbol for these. So remember that when I go by this acronym, the acronym is basically the elements in words. So you can see it's potassium, because K is for potassium, Na is for sodium. So if you notice here, the P, S, C is for the name of it, not the symbol. So it's the elemental name, the first letter in the element, and not the symbol for the element. Alright? Because as we know, potassium is a K, sodium is Na, calcium is Ca, magnesium is Mg, aluminum is Al, zinc is
Silver Ag.
Yeah, zinc is Zn. Good. Zinc is Zn. Iron is no. Fe. No. It's coming from ferrous.
Yeah, ferrous. Yeah.
Yes, there's some Latin or Greek or something. Alright? And then lead is Pb. H. Copper is Cu. Silver is Ag. Good. And gold is Au. But you don't really have to know this gold part. Just know the general trend. Group 1, group 2, group 3, and transition. So what are some of the physical properties of metals? Physical properties of metals. They are good conductor of electricity and heat. We all know that, right? Metals, the wire that they use in the cable to conduct electricity. If you check the pot and the stove, it can get very hot. So those are physical. When I say physical properties, they are properties that element will have, which it will stay and does not change its form. So chemical properties normally when you react like a metal and it forms some other compound. When we talk about physical properties, the metal will stay in the metallic form and show those properties. Alright? So they also are solid at room temperature, except for mercury, which is a liquid. Alright, so all metals are solid at room temperature, except mercury, which is a liquid, which we normally would use like in the thermometer. You know those old time non-digital thermometer where the mercury will go up in the little bulb. So the old time thermometers, they are made of mercury. Alright? Other properties of metals, they have very high melting and boiling points. So metals, they have very high melting and boiling points. Alright? They normally have high density, and density is how compact the substance is. So they have high density, so if you should take a piece of metal and put it in some water, it would sink. That is a means in which like a qualitative way which can determine if something has high density. So we would say that the metal is of a higher density than water because it would sink in the water. Alright, so how compact the atoms are in the element or the compound in the element would call the density. Alright? They are also what we call malleable and ductile. Malleable means they can actually shape into different forms, so we can melt them and shape them into different forms. Just like for example the doorknob can shape it, and it can also like stretch out. Ductile means it can go into long wires to make like electric cables. Alright? So those are some of the physical properties of metals that you just need to know about and read about. But those won't be any major aspect of the exam. The exam normally come hit you with the reactivity. So we're all comfortable with the reactivity series, right? Good? Yeah. So remember that most reactive metals will lose their electrons easily. So they will readily react with water, hydrogen, or oxygen. Like sodium, potassium, sodium, calcium. The higher you are in the reactivity series, the more reactive you are. The lower, the least reactive. As we know, silver and gold. Why they normally would be so pricey and expensive is because they stay pure in the environment, so they don't react with others with oxygen or water. Like silver and gold, they will stay. Like if you put a piece of gold out there in the rain,
because the steel rust.
Yes. So like if you should put a piece of gold or silver out there in the rain and the water, it will stay shiny forever. It will not form any layer on it like any compound like rust or oxide, right? So like iron would form like iron hydrated, iron oxide and silver. Diamond is non-metal, but it's a special type. We will discuss that when we reach non-metal, but it's not a metal, but it's very strong. Alright. So metals react by losing electron, right? So for example,
Sarah one also.
okay, English will. Alright, good. I'm proud of them in English, alright? So I lose in electrons, right? So for example, if we have like sodium, it would actually become sodium plus an electron. Alright? So you can see that it's actually gonna be losing electrons to form the sodium compounds. Alright? Now, for example, when we look at reactions of metals, so if we, example is
lose again.
Reactions of metals, right? So one react with dilute acid, right? Example, hydrochloric acid or sulfuric acid. Clear? And metal plus acid, hydrochloric acid, sulfuric acid. A metal will react with the acid to produce a salt and hydrogen. Right? Metal will react with oxygen to so metal plus oxygen produce metal oxide. be metal plus metal plus water produce the metal hydroxide plus hydrogen. Right? And then finally we have the metal react with steam. So it is basically water vapor, right? Alright? And so it's going to be metal plus water vapor, or put steam, produce metal oxide plus hydrogen. Alright, so I'm just going to discuss the principle behind these and give you some examples of them. Alright, so remember now 1, 2, 3, 4. Alright? So a metal will react with dilute acid. Alright, so it's actually going to produce the salt plus hydrogen. You have to bear that in mind, alright? So sometimes for some of the reactive metals, the hydrogen that is produced will actually burn in oxygen to produce water afterwards. But for example, sometimes we put, like, for example, potassium in some acid.
Metal plus acid.
Yes.
To react with the water.
No. The metal plus the acid is going to form a salt. So it's going to be the metal plus the anion from the acid. So when we say a salt is normally a metal plus an anion, right? So, like, for example, if we have sodium, sodium chloride would be a salt. If we have potassium, potassium chloride would be a salt, alright? Plus the hydrogen, right?
And calcium too?
Yes, calcium would also react the same way, with acid to produce salt and water, and hydrogen, sorry. Salt and hydrogen, my bad. Right, so the metal itself is going to react with the acid to produce a salt plus hydrogen gas. The metal will react with the oxygen to produce metal oxide. For example, if we should leave a metal in the air, it will just form an oxide layer to form metal oxide. A good example of metal which form an oxide that is actually protective would be like zinc. You see the zinc, when zinc reacts with oxygen, it will form zinc oxide, but that oxide will actually stay and protect the zinc below. Alright? Unlike iron, which when the iron form iron oxide, it will actually flake off and degrade the metal. Alright? So some metal oxide will adhere to the metal, some will degrade. Alright? So the acid, the oxygen, and then water or steam. So just to note that when we react the metal with the water, it produces the metal hydroxide and hydrogen, right? While if we react it with steam, it will produce the metal oxide. Now, why it normally produces the hydroxide when we have it in solution is because normally the oxide, if you form a metal oxide in water, it's actually going to dissolve to form the hydroxide. So technically, as long as we have the metal in the water, the oxide that is formed initially is going to dissolve to form the hydroxide. So that is why you have to bear in mind that initially the oxide will be formed, but it will dissolve in water to produce the hydroxide. Because all metal oxide normally dissolves or reacts with water to produce the hydroxide. So that is why the end result, if we should drop a piece of reactive metal in water, it's going to produce the metal hydroxide plus the hydrogen gas. While if it's the steam, it's just going to form the metal oxide. Because remember that we form this the water vapor, the metal oxide that is formed is not going to be able to dissolve in our water to really react to form the hydroxide. So that is the difference between when you react the metal with the water, different from the vapor. You can see the difference in product that is formed here. Clear? But in all cases, we're going to produce hydrogen gas except when we react it with the oxygen, right? Because in all the other cases, if we have water or if we have acid, you will have the protons there which would actually be reacting to form hydrogen gas as a byproduct. But it's only in the case in which you react the metal with the oxygen, we form only the metal oxide. Clear? Oh, why this form here?
Yeah.
No. I'm saying that if we put the metal in water,
Yes.
liquid, it will form the oxide initially, but the oxide is going to dissolve to form the hydroxide
Oh, it's
in the water that is there.
Oh, the oxide.
As opposed to oxygen.
As opposed to if we have the water vapor. Alright, man, steam is water vapor, so I want to put liquid water and water vapor.
When we use it with oxygen, it becomes metal oxide.
If we use the metal with
You
oxygen,
get metal oxide.
you get metal oxide. But if you use it with water vapor, you get metal oxide as well. That's what I'm saying.
Yeah.
Plus hydrogen.
Yeah. And if you use it with metal and plus water, you get
metal-
metal oxide.
metal-
And you said
metal-
why get the hydroxide is because it has
Hydroxide, because if you have an oxide in water, it's going to actually react again to form the hydroxide.
Okay.
So